The next three sections are going to be dedicated to talking about each of the three major types of fossil fuels: coal, oil, and then finally natural gas. So we'll talk about what they are, how they are obtained, and some of the environmental and health consequences of their use. And we're going to start with coal. So, coal is a combustible black or brownish black sedimentary rock containing a high amount of hydrocarbons. And there are four different varieties of coal that are ranked based on their quality, which are, starting with the lowest quality, lignite, subbituminous, bituminous, and then anthracite. And as this illustration shows, the highest quality coal is that which has been in the ground the longest and has experienced the most heat and pressure, whereas the lowest quality and the youngest, the type of coal that we see here called lignite, was formed under the least pressure. And note that anthracite is not shown in this picture. It only goes up to bituminous. And the consequence of the higher temperature and pressure conditions means that the percentage hydrocarbon content increases, and therefore the density, the amount of energy stored, increases. And also the moisture content decreases because more water gets squeezed out, so that makes the higher quality coals more easily combustible. Coal is obtained via one of two types of mining. The first one is strip mining, which is also called surface mining. And strip mining is used for coal that is in the surface layers of the Earth's crust, usually less than 200 feet underground. And it involves using large machines to remove what is referred to as the overburden, which is the soil and rock layers located above the coal. And this process strips away large sections of the Earth, which you can see in this aerial photo of the Kayenta coal mine, which was a strip mine that operated from 1973 to 2019 on Navajo Nation, and it was shut down at around the same time that the Navajo Generating Station coal-fired power plant was shut down. We'll talk about that power plant in a few moments. One strategy that is sometimes used in surface mining of certain locations is mountaintop removal, which is where the top portion of a mountain is blasted away with explosives to allow access to the coal deposits. The other type of mining is called underground mining, sometimes called deep mining, and this approach is used for deeper coal deposits that are over 200 feet underground. And to access those deposits, mine shafts with elevators are constructed, which can extend thousands of feet deep and go for many lateral miles under the surface of the Earth. Once the coal is mined, it has to be processed to prepare it for combustion in a coal-fired power plant. So the coal will be cleaned to improve its heating value. Heating value is a measurement of how much energy can be obtained from it. And this cleaning involves removing impurities like dirt, ash, and sulfur. And then the coal is transported to the power plant. 70% of coal in the US travels by train for a significant part of its journey, but it may also travel by ship or by truck, or it can even be crushed and mixed with water to form what's called a slurry, and that's sent through a pipeline. Once at the power plant, the coal will be pulverized into a fine powder in order to maximize the amount of combustion that you get out of it. The powder gets mixed with hot air and blown into a furnace where it is burned, and the heat energy emitted from the burning boils a stream of purified water that's piped through the furnace, and the steam that's produced from the boiling water then turns the blade of a turbine that's connected to a generator, which produces electricity and sends that electricity off onto the grid. And then the steam that was produced from the boiling of the water then passes through to an underground condenser where millions of gallons of cool water that are usually coming from a surface water source like a river will be used to cool off the steam until it condenses back down into liquid water, from which point it will be recycled back into the boiler to be turned into steam again. And meanwhile, the surface water that was used to cool it is returned back to its source. So this gives you a sense of what coal goes through from beginning to end over the course of its use in energy production. And these various steps of the process have consequences for the environment and for human health. When it comes to the mining of coal, strip mining destroys ecosystems and threatens biodiversity by carving away the top layer of the earth and destroying the organisms that reside there. This impact is significant, especially because 66% of the coal mining in the US is strip mining, which is an artifact of the reality that strip mining is simpler and less expensive to carry out than deep mining, so it's the more common approach. In addition, mountaintop removal results in dirt and sediment and pollutants being deposited into waterways, which harms aquatic ecosystems. The photo on this slide is of the strip mines in the Miami Globe district of Arizona, and it was taken in 2007. And these are actually copper mines, not coal mines, but the principles are still the same. You can see the areas where the mountaintop removal has taken place and the topography of the land has been altered. And obviously, the ecosystems have been severely affected, with large parts of the natural landscape being destroyed. In the US, there are laws that require that dust and runoff from coal mining operations be controlled, and that the area be restored after completion of the mining activities. But under these laws, the restoration is mostly about stabilizing the rock formations to prevent landslides and stop erosion, rather than reestablishing the ecosystems. And it is very challenging, perhaps impossible, to reestablish the same ecosystem in a place that has been strip mined. And even when an effort is made, the quality of the soil is so poor that the standard for restoring forested areas in the US isn't actually to get them back to a forested state, but just to try to get them to become grassland, which is a different ecosystem entirely. Underground mining has its consequences as well. One of these is that methane has to be vented from the underground pockets that are excavated for coal mining in order to make the operation safe. And methane is a potent greenhouse gas. It has a global warming potential that is 27 to 30 times more powerful than CO2 when considered on a 100-year timescale. So even before the coal has been mined and burned, the process is already a polluting one. Underground mining can also lead to ground collapse and sinkholes above mine tunnels, which alters the topography and threatens ecosystems. This photo here is of a sinkhole that was created by the Uralkali potassium mine in Berezniki, Russia. Another consequence is the runoff of acidic mine drainage into waterways, which contaminates and damages ecosystems. And this consequence is not exclusive to underground mining, it also applies to strip mining. The photo here is of a part of the Rio Tinto in Spain, which is contaminated with acidic mine drainage. And then when it comes to the environmental impacts of actually burning the coal combustion emits sulfur dioxide and nitrogen oxides, which cause acid rain. And of course, as we've learned, carbon dioxide is produced from the combustion of fossil fuels, including coal. So that covers the environmental impacts, but we also should mention the human health impacts. You may have heard of a condition called black lung at some point in your life. The medical term for this is pneumoconiosis, and it's a condition where the lung tissue is damaged from the buildup of coal residue that is inhaled. It's a condition that's seen in people who work in coal mines for prolonged periods of time. In addition, the burning of coal emits airborne pollutants that affect even people who aren't directly exposed to the coal. It emits ash residue, which contributes to particulate matter in the air if it's not scrubbed out of the coal smoke before it's released. In the US, this ash is scrubbed and then stored at the power plant or placed in a landfill, but there can be problems with the stored ash leaching into the groundwater. Coal combustion also produces, as we noted on our previous slide, sulfur dioxide and nitrous oxides, which not only contribute to acid rain, but also are criteria pollutants that contribute to a variety of cardiovascular and respiratory diseases. Coal emissions are also a significant source of toxic heavy metals, which are implicated in neurological and developmental conditions. And coal is the single largest source of mercury emissions into the environment. You may know that mercury is also a toxic metal, and actually, mercury in the air isn't the problem, but when airborne mercury emissions settle into water, they are transformed into methyl mercury, which is highly toxic, and also it is bioaccumulative. Animals, including humans, do not have a way to excrete methylmercury from their bodies, so over their lifetimes it accumulates to higher and higher levels, which also means that it biomagnifies throughout aquatic food chains. So organisms at the lower level of the food chain get low levels of exposure, but as they're eaten in large quantities by the organisms above them on the food chain, the mercury levels accumulate in those higher level consumers to the point where they can be dangerous for us to eat. And mercury consumption is most dangerous for children and pregnant women, and this table from the EPA gives you a sense of which fish are lower on the food chain and therefore lower in mercury and considered generally safe to eat. Examples include anchovies, herring, scallops, shrimp, clams, cod, crab, as opposed to those that are higher on the food chain, like sharks, swordfish, king mackerel, which have some of the highest mercury levels. And while it's difficult to quantify the impact that coal combustion has on human health, there is one report that I can share with you on a coal fired power plant that is close to home, or it used to be, which is the Navajo Generating Station, which was a power plant that operated on Navajo Nation for many years and was supplied by the Kayenta coal mine that you saw an aerial photo of a few slides back. This plant was decommissioned in 2019, and on the right you can see a shot of the demolition of the smokestacks in 2020. But back when it was still operating in the mid 2010s, it was burning 8 million tons of coal every year, which released 34,000 tons of nitrogen oxides, 15 million tons of carbon dioxide, and 500 pounds of mercury annually. And a nonprofit group called the Clean Air Task Force estimates that these emissions were likely to result in more than 128 million in healthcare costs related to heart problems, asthma, and other conditions brought on by the pollution emitted by the power plant. In recent years, there have been more efforts to make coal-fired power plants cleaner and less polluting. And these include what's branded as clean coal technology, which removes the chemical components of the coal that lead to sulfur dioxide and nitrogen oxide emissions before the coal is burned. Scrubbers are also standard technology in the US. These are mechanisms installed within the power plant that remove pollutants from the smoke before it's released. Carbon capture and sequestration is a technology that's being investigated, which would involve separating out and capturing the carbon dioxide emissions from the smoke and then storing them permanently so they can't contribute to warming. And when it comes to mining operations for coal, there are still efforts to rehabilitate land that is affected by coal mining for other purposes, including landfills, airports, and golf courses.